Hello, this is Paul from Foresight Tech. In this lecture, we were going to learn Squeeze Theorem. Okay, and we will use this theorem to solve a little bit complicated limit. Before the Squeeze Theorem, so we need to learn comparison theorem, and we will use comparison theorem to prove the Squeeze Theorem later. What is comparison? If we have two functions, if one function f is lower than another function g, and then we have the result. The limit of the function f is also lower than the limit of the function g. All we can say is this: if f is controlled by another g, and then the limit is also controlled, the limit of f is controlled by the limit of g. And let's look at the graph. See, and the function f is controlled by the function g, or the function f is lower than the function g. And then we look at the limit of both functions at a, or when x approach a. Can we see? And at this point, this height is the limit of f, right? And this height is the limit of g. Of course, the limit of f is less than the limit of g. Okay. And we were going to use another. And usually we will say is this: if the function is lower than, and we take a limit to both sides, we get the limit of f is lower than the limit of g. Okay, we can take the operation of limits to both sides. We don't need to change the sign. And then we will use this to squeezing theory. So here is the squeezing theory. So we look at the statement. If a function gx is squeezed by another two function f and h, and the limit of both function f and h is the same, equals L, and then we have the result. Okay, the limit of the middle function g has the same limit. Let's look at the graph. We say a function g is squeezed by another two function, which means the middle function g is the middle function is g, the upper function is h, the lower function is f. Can we see? The second, if the upper and the lower function have the same limit as x approach a, which means this. Okay, look at what the result we will get. Of course, because g is squeezed, so in the middle should be also the same limit L. Okay, so the result should be super easy to get it, right? This we call the squeezing theory. We have another understanding, another notation, and usually we will say f is squeezing by these two functions. Usually these h functions we call it the upper bound, and f we call it the lower bound, which means what? And the function f is controlled by the lower bound, and the upper bound is controlled by these two functions. And the result is this: if the two functions as x approach a has the same limit, and then the middle function has the same limit h. Okay, the graph exactly shows us. And we said we have a comparison, right? So we can use a comparison to exactly prove why this is true. Can you see this? Because we have gx is controlled by the lower bound f and the upper bound h. Therefore, do you remember comparison? Okay, we can take a limit to the left, to the middle, and to the right, which means take a limit to each part. See, what do we have? We will have limit f should be less than the limit g, and less than or equal to the limit x approach a and h. Okay, so this is what? This is comparison, right? Because g is controlled by both functions, so the limit is also controlled by the both limit. And then we look at what it is. Okay, and from the results, the statement tells us the limit of the lower bound is L, and the limit of the upper bound is the same number L. Can you see this? So what do we get? We definitely get the middle one should be equals L. Why? Because this number is greater than or less than greater than or equal to L, and less than or equal to L. The only choice for this number is equals L, right? Okay, that's by comparison. So we have the squeezing theorem. So let's look at the two questions. So how to use the squeezing theorem? Here is the questions. If we have a function f, can we see? Function f is squeezed or controlled by the lower bound function and the upper bound function. Okay, now we look at the limit of the function, the middle function, as x approaches 4. Do you remember the squeezing theorem? All we need to look at if the limit of the the lower bound equals the limit of the upper bound. If both limit equals to each other, then the middle function should have the same limit. So we're going to see if this works. We're going to look at the limit of the lower bound. So which means I'm going to take a limit. We're going to look at the limit x approaches 4. The left is 4, x minus 9. It's equal to what? Okay. This is a polynomial function. The polynomial, they take a limit, we can use the direct substitute, right? Direct substitute the x by 4, which means 4 times 4 minus 9. What do we get? We get 7. Okay, which means the left, the lower bound has the limit 7. Now we look at the upper bound. If it's the same, we'll find the middle, right? Okay, we're going to see the limit x approaches 4. We look at the right function. We call the upper bound. Okay, is x squared minus 4x plus 7. Okay, is the same. This is a polynomial. Directly substitute. So we have 4 squared minus 4 times 4 plus 7. This is 0. So we get what? Yeah, we also get a 7, which means the same. Now what do we say? So we can say by the squeeze, right? By squeeze theorem. Okay, we know the limit of the middle function is also 7. Okay, so we have the results, which is x approaches 4. The limit of fx is also 7. And these are the questions. Okay, so one more question. How do you use the squeezing theorem? Look at these questions. Okay, this question is a little bit different from the previous question. Why? Because we don't know the squeezing function, right? We don't know what the lower bound function and what the upper bound function. So we need to find the boundary or the squeezing functions by ourselves. Okay, how do you find? Can we see this? So how to bound the functions? So we see we have two parts on this big function, right? The first function is already simple. X squared is the power function. We don't need to do anything for this part. We can do something for this part. The second part, which is a little bit complicated, is a sine function. But we can control this function, right? Because what? Because we know this. The sine function is between -1 and 1, which means what? Which means that the minimum of sine is -1, the maximum is 1. So the value of sine always between -1 and 1. So we say -1 is the lower bound for this part. +1 is the upper bound for this part. So we can control this function first. Let me write down. We can control. Okay, the first. So what do we get? We get this sine 1 over x is controlled by 1 and -1. Okay, so good. We can choose this part. So how about the first part? We can multiply. Okay, we can multiply x squared to each side. Okay, so we can do this. We can multiply each side or each part by x squared. See, we get the squeezing. Okay, so the middle is x squared times sine 1 out of x. So less than x squared, right? 1 times x squared is x squared. Negative 1 times x squared is a negative x squared. Okay, because x squared is a positive number, so we don't need to change the direction. Okay, good. So now it's almost the same as the first question, right? So we control this big function. The lower boundary is negative x squared. The upper bound is x squared. Okay, so now is squeezed. Okay, so how to find the limit of the middle? We need to look at the limit of the lower bound and the limit of the upper bound. If they are both the same, we find the solution, right? Okay, we're going to see. Yeah, definitely they are the same. Okay, so we look at the limit as x approaches 0. The left equals how many? Equals 0, right? The power or polynomial direct this up to the equals 0. And also equal the right. And this the limit of the upper bound. How many is the same? Is 0. So now what do we get? Okay, and both limit of the lower boundary and the upper boundary has 0. Okay, so the middle function is the same. Therefore, so we by Squeeze Theorem. Okay, and we have the limit of the middle function, which is x squared times sine 1 out of x equals the same 0. Okay, so we find it the solution. That's all. Thank you.